Okay, so week 13 is all about matrices. So this is going to follow very closely some of the things that you will need to do in Math 103, so you'll be able to use R to help you to support your work in Math 103. So in order to create a matrix in R, we use the command matrix, which works in a similar way to the C command, which was, remember, to create a vector, we used the command C. So X is C for combine a range of numbers into a vector. Now for matrices is this function matrix, and a good starting point here is to just bring up the help on matrix. So it's question mark matrix, brings up the help file, and here is the how we create the matrix. So let's just work through. So matrix, well, the way we do it is we actually supply a vector. So let's have a vector 1, 2, 3, 4. Okay, well let's first of all try what happens there, and you can see it's actually created a matrix. Now this is different from just 1, 2, 3, 4 on its own. If I run that as well, you can see the difference. So it has arranged the numbers 1, 2, 3, 4 in this 4 by 1 matrix rather than just a vector with 4 entries. So in particular this is a 2-dimensional object and this is a 1-dimensional object. So just to show you the difference, if I call this X and this Y, X, Y, now I could access the entries from X in a 2-dimensional manner, which is what we'll be covering in this workshop. So if I want row 1, column 1, I access that like that and get the number 1. For Y, if I tried to do that, this doesn't work. It says incorrect number of dimensions, because this is a vector, it's only got 1 dimension, so there's only one subscript that's required there. So the problem here is that what this has done by default is it's made this 4 by 1 matrix. If I wanted a different shape, I need to specify either the number of rows or the number of columns. So if I say I want two rows, then it will give me the appropriate size matrix. What happens if I specify too many rows and columns? So here I've 2 rows and 6 columns, so that suggests 12 entries for the matrix, but I've only supplied 4. What I will do is it will recycle the vector to fill in the entire matrix. So we've got 1, 2, 3, 4. It's then got to the end of its vector, so it's run out of space. So now it starts again, 1, 2, 3, 4, 1, 2, 3, 4. So let's just change this so that it is the right length, and that gives us something like that. Now another problem, it might be inconvenient to fill column by column. We might want to fill row by row. If we want to do that, we just specify the optional argument by row equals true. So if we do that, you can see that it's filled along the rows in that particular order. And again, if it doesn't have enough entries in the vector that we're using to fill the matrix with, it will recycle the elements that are already there. Another thing that we can do, which can be convenient, is we can build a blank matrix by specifying NA. So that just builds an empty matrix, and in fact that's exactly what happens if we don't specify anything there. So if we just say we want a matrix with 2 rows and 6 columns, it just generates that matrix and fills it with NAs, and then we can fill in the values that we want later. Okay, so let's just go back to our matrix that was 1 to 12. Now how do we access individual elements of this matrix? We've already hinted at how we might do that. If we want the 2nd row and the 4th column, we do that and we get the number 10, which as you can see from here is the correct value. We can also replace specific values in the matrix with new values. So we can put the value 1, 1, 1, 1 into position x24, and if we look at that matrix again, we can see that that replacement has indeed occurred. That can also be used, of course, in conjunction with starting off from a blank matrix. So if our X matrix is blank, We then put the value 1111 into position 24, and that's then the only position that's filled so far. As well as subsetting individual entries of a matrix, we can also ask for individual rows and columns. And the way we do that is, so let's put this back, is we just leave blank some of the elements of the index. So if we want, say, just the third column, we don't specify which row we want, and if we don't specify which row we want, we get them all. So that gives us the entire third column. We could also get the third and the fourth column, like that. Now here's a big subtlety that we have to be very, very careful about. You can see that when I just asked for the third column down here, it's converted that into a vector rather than a 2x1 matrix. That's something to be very, very careful of. And you'll find when you're writing more complex code that can be a problem. One way around that is to use a command called as.matrix, which forces whatever this output is to behave like a matrix, even so this sort of stops it from converting it into a vector. Another thing that's similar to as.matrix is is.matrix. And here we can see that X itself is a matrix, so that's true. But by default, if we just extract a single column, that converts it into a vector, so that becomes false. Whereas if we extract multiple columns, that's still a matrix, so that's true. Another handy thing we can do is combine, say, multiple vectors together into a matrix. So say if I have one vector called X that looks like that, another vector called Y that looks like that, then I can make a matrix called Z using the command cbind, so that means bind together in columns X and Y. And if I do that, you can see that what I get for Z is a matrix with an X column and a Y column. Alternatively, I could combine those in rows, which would then look like that. Another subtlety here, if the lengths of X and Y don't match, the shorter version will be recycled. So you can see here that X has run out of entries, so it's gone back to the 1. Now it's also helpfully printed a warning message here telling me that essentially this is telling me that these things aren't multiples of each other. So it's had to partially recycle X rather than recycling an entire version of X. Whereas say if Y was exactly twice the length of X, then we wouldn't get that warning. It would be happy with that because it says, well, that seems to be a sensible thing because X has run out, but then it's been recycled fully in order to match the length of Y. Okay, so that's all for so far in week 13. We'll move on to some more advanced operations with matrices in week 14.